Okay, we're gonna start in just a few minutes here. 4 minutes to be exact. I don't know what it is. It's pretty bad. Yeah. That's what it was trying to be, but it is getting a little too phallic for me. we'll leave the jollies to someone else. Just checking in with you guys in Victoria. Once you have joined the stream, just let me know if you can hear me and if the audio is clear and loud enough for you guys on that side. Awesome. Thanks so much, Benjamin. Great. So everyone here, we're going to get going with lecture now. More than welcome to stay where you are, but as you know, some of these technical lectures, and today we'll be doing some coding. I will do my best to keep the text as large enough as is readable for you guys in the back. If it is too small at any point, just let me know. But you can also come closer if that's a bigger issue for you. Today we are dealing with JavaScript objects. Exciting topic, one of the most useful ways to store information in JavaScript. But before we dive too much into that, maybe just a little preface of who I am. I've seen a lot of your faces around. I didn't lecture yesterday. I maybe got to talk to one or two of you on Monday, but for those of you who haven't met me yet, and for those of you in Victoria, my name's Travis. I'm a full-time instructor here. Oh, I also missed your guys' like nice intro and quirky facts. I don't know anything quirky about you yet. My background, I did a degree in computer science at Simon Fraser University before I knew that boot camps existed. So arguable whether I wasted my time there, but I got something from it. I really like rock climbing and bouldering in my spare time, so if any of you guys are into that, I'd love to talk to you about it. Of course, I'm a web developer. That's why I'm here lecturing and why I help out with the boot camp. But I also really enjoy just video games and like to think of myself as like a hobbyist game developer, although the amount of actual work in that I've done recently is very low. If you guys have any other questions about me or whatever, we can chat. But I guess we can jump into the lecture now. Like I said, we're going to be focusing on objects in JavaScript. Some topics we're going to hit are just the fundamentals of what are objects, how do we use them, what are the syntax like. We're going to talk about primitive data types, and we're going to look at the difference between a function and a method, which are very similar, but has something to do with this objects thing. Just as a preface, I know yesterday Andy probably took you through all of this and what it means to be in a technical interview. So this is probably a review, but just in case. Throughout these, the purpose of technical interviews is to demonstrate technical concepts. It's not the best case or best scenario or type of learning to get exactly how to do syntax. It's more what are the macro ideas, and really the lectures you can draw from their experience in the dev world at large behind the different topics they look at. So you don't want to be trying to code along. It's going to be hard with most lectures. Maybe through this week you could manage it, but going forward might not be a best practice. And it's really, the benefit comes if we can make this a discussion as a group. And we can kind of, back and forth. I get input from you, you give input to me, we have questions, and we get that interactivity. Without the interactivity, this could be just kind of a recorded lecture that you watch and still possibly get benefit from it. But the real opportunity of you guys being here or being there on the stream is that we kind of get the back and forth. So as much as that is really nice. But objects, I guess before we look at this, in JavaScript, how or what ways do we currently know to store information? How do we remember things as it is in JavaScript right now? Declaring them as variables. And what types of variables do we have? Or what types of variables can we use? Strings, arrays, booleans, numbers or integers, null, undefined, which is also another type. So we have all these different ways that we can store information. An object is just another way of storing information. By and large, like programming is the idea of taking mostly real-world problems, or at least like human-created ideas, and trying to encapsulate them into some form that a computer can understand. So when we're talking about arrays, we're talking about numbers. Today, when we're talking about objects, it's often the attempt to take real-world information and like what is the best way to store it in our program form. So when we look at arrays, arrays are lists of things. They're really good for storing lists, I guess. But if we have a number of things and we want to just like put them all like we have a shelf in the real world and just slot one thing at a time, we have a store for arrays. Objects, I would like you guys to think of objects as maybe, get rid of those guys, like phone books, dictionaries, somewhat mailboxes. Those are kind of synonyms. or things in the real world that reflect what an object does within JavaScript. So they're a way of remembering or storing information. Other names for them or other ways they're described maybe in other programming languages. I don't know if you guys have talked about other languages at this point, but for the most part, the skills and knowledge, the focal kind of set of programming tools that you're learning will be very, like, you will be able to translate them to most other languages. So things like loops, conditionals, variables, all of these things are just general concepts of programming. An object works like a phone book in JavaScript. In other languages, they might be called an associative array, a map, a dictionary, or a hash. We don't really need to concern ourselves or memorize these right now, but just as a catch that you might see those terms used to describe objects out there in documentation in the world. So what are the properties of a phone book? How do you store information in a phone book? You have a name that you can look through, and the whole phone book will be indexed by the name, meaning ordered alphabetically in a lot of cases. For larger phone books, you might also have an ordering through city first. But if we think on a smaller scale, each page is like organized by name. For objects, this is called the key. And then when you find someone's name, you have their number to the right. In an object, this would be referred to as the value. So objects, you're storing data in key value pairs. You're storing a piece of information with a label attached to it. So that's one benefit there. You know, similar to arrays, objects are just going to store groups of information. But the benefit of using an object is now that we just stick a little sticker on it that says, this thing that I'm putting here is called this, or has this label or key associated with it. Other like structures that use this are like dictionaries, mailboxes to some degree. We could also use mailbox potentially to describe like arrays as well, because when we have an array, they're indexed by numbers. A mailbox is, for the most part, indexed by numbers. And then we have objects, which we use in JavaScript with a key of a string, and then we can store as a value any valid JavaScript value. So before we go too much further, let's actually get some like useful examples. The tool I'm going to be using today is the console in Chrome, the developer tools. An alternative to using this would be your command line and using the node REPL. So hopefully you guys have experimented in here a little bit, where we can just experiment with JavaScript. So I'm going to let a thing equal 5. I can console log the thing. This is useful, especially when you're learning new concepts. It's interactive. You can make little experiments to test what you think you know. So given an array equal, I like playing around in these just to like test my syntax. How do we grab the number 3 from this array? So ARR brackets 2, and we can see what the console is putting out. So we're going to use this same kind of, creating small structures and testing on it with objects. We could be doing it in REPL. We have a similar interactive terminal with, just one moment, with DevTools. The only reason I like using this console is because it does a little bit better syntax highlighting for us. And when we do objects, we'll see some other benefits that are going to come up. Yeah, you had a question?
The screen zoom looks a bit weird. Can you go back to the terminal?
Yeah.
Yeah. The 3.
Ah.
It might be something with the monitor.
No, that's worse. Let's see. Yeah, it's not my zoom. It's probably the monitor settings. I'll be conscious of that. I'll try and do stuff on the right-hand side like we have here. There's, just so you know, nothing interesting is happening over here. It's hidden, but trust me, there's no secret knowledge over there. I know that's actually super important for you guys in Victoria as well, so let me know if I'm cutting anything off. Sweet. So let's make our first object. So this is the syntax for an object. We declare it just like we would any other variable because it's still a variable. We give it a name. And then you create an object with an open curly bracket and a closed curly bracket. If I do an open and closed curly bracket with nothing inside, that is still a valid object. It's just an empty one. So I could create an object now by hitting enter, and that is fine. If I look at that variable, I see that it is an object. JavaScript consoles will print objects, even though they're just data structures to the program. They will print these objects in this form so we understand that they're objects and we can see the different data that's stored inside of them. Another way I can create this object is to say this is going to be a list of dogs. And I can initialize it with a couple key value pairs, as many as I would like. So I'm going to have, if I'm having a group of dogs, it maybe doesn't make sense to index them by dog because we know they're dogs already. So I will maybe index them by their name. And then the value can be just a string about this dog. Such a good boy. Actually, Lola's a girl, but I think you call any dog a good boy. So then we have that dogs object created. We can look at it and we can see the key value pairs that occur in that object. This is not helpful at all unless we can pull out the data from this object or put more stuff into it. So with arrays, we know how to do that. How do we add and or how do we get and add stuff to an array? A loop? Yeah, if we want to get everything from an array, we can iterate through it. What if we want to grab just one thing? Yeah. We can look up the index. So I'm going to create that test array again. Test array. And I'll just give it some names. Oops. So in a real application, we might have to dynamically find out which index we wanted to look it up. But in this case, just because we can see what we just entered, and we already went over this, we can get something from this array using its index and these square brackets to say, if I want Sam, our arrays are indexed from 0 onward, so it's at position number 1. And we get our value back. We can use exactly the same syntax with objects, but our objects are not indexed by numbers. It's not 0, 1, 2 with our object. It's Lola and other dog names depending on what we put in there. So with dogs, I can go dogs, square bracket, and it's actually giving me the hint right there that I should use Lola. And I'm retrieving the value, such a good boy. I guess one thing to point out too here, you see that I'm not console logging anything here, but I'm seeing the value popped out. That's not because my program is doing something secret and logging this. It's simply the REPL, the read, evaluate, print loop, like the live console that I'm using. Anytime you do any statement, it's letting you know the value of that statement. So in a traditional program, anywhere where we see this left pointing arrow, that would not be printed to the console. If I copy this same code, put it in a JavaScript file, and run it with Node, I would be receiving no output at this point. Let's see the difference. If I do a console log of dogs Lola, I get, this is the console log. Here is what the result of this statement was. So this statement does not return anything. It does not evaluate to anything. So I'm getting an undefined. And I'm getting the little left arrow. So if that might be a little bit confusing, but let's focus on these right pointing arrows for output and the left pointing arrows just to see what we're currently looking at. Yeah? Yeah, super good point. So the question for you guys in Victoria is, when I'm trying to access a value from my object, so my dogs object, do I need to reference the key being Lola, with quotations? Or could I do something like this? And those are exactly the questions I want you to ask when you're working with objects. And outside of the context of the lecture, to solve that problem, I want you to just bring up your console before you Google if that's possible and just try it. There's no stakes to getting anything wrong in this console. And programming in general, for the most part, you want to be really experimental. It can be easy early on to kind of have a fear of writing code that's going to have errors or do wrong things. That's how you're going to learn for the most part. So if we just experiment and we go dogs, and I just type in Lola, does anyone have a hypothesis on what will happen? Like, what are some options? Undefined. OK, let's try. So we actually get an error, uncaught reference error, Lola is not defined. So when I'm going dogs Lola, I have kind of two things that are happening here. I have my syntax where I'm taking an object and trying to access something. And then I have whatever my statement is in between those two brackets. They're going to get evaluated separately when we're thinking of how the program runs. If I just write Lola on a line by itself, what is my program trying to do? Yeah, it's trying to find the thing called Lola, or the variable called Lola, which doesn't exist because I have not declared it anywhere. So if I just do this, I get the same error, uncaught reference error. That thing is not defined.
So I know we've done this the other day. How do you pull up that console with the editor in
Yeah, super question. So you can write, whoa. So you can right click and do inspect. That's one way. The other way is the triple dot menu, and then you drop down to more tools, and then you go to developer tools. That is the worst way to do it, obviously, because it's hard to find. You could also look up the shortcut if you're using Mac. It's Command Option I, and that'll pop it up. Mine's popping up in a separate terminal or a separate window because I have just like undocked selected. Most of the time, it's just to come up next to your Chrome browser. The only reason I'm doing this version is so we can have it next to our notes. So good question. In this case, the same as this case, when we're using just the name, it is looking for an object first. So whatever we have between these square brackets is going to try to be executed by the program, which will lead us into a really good distinction between this and this. We won't jump there yet, but we'll deal with the second question that we had, or second issue that we had, which was we now can get stuff from our objects. We now want to put something in. So we have dogs. It still looks the same. We can get this one key, value from our key value pair, but now we want to add in another dog. And the syntax is very similar. We use the square brackets. We use quotes to say what the new key will be. All of our keys in JavaScript have to be strings. So we can index any piece of information in our key value pair, but the left side is going to be a string. You'll notice when I created this, the key did not have quotations around it like we normally would see with a string in JavaScript. And this is just because JavaScript implicitly knows that any key that we're using is going to be a string.
Is there any order involved in the, so within the different keys? So say you have 3 keys. If you
So from everything matters to a degree. That does change the order we'll see the keys pop up, say when we print this object, or even how they're probably stored in memory. But from our standpoint and how we're acting with objects, for the most part, that doesn't matter. Because, and this is one of the strengths that we'll see with objects, when we're grabbing pieces of information from our object, we don't care what order they're in, and we don't have to do a search to find one piece of information, as long as we know the key. So does anyone have a dog? Milo. And what's a string to describe Milo?
Well, you already said the good boy.
Oh, the bestest boy. Okay, we got a lot of good boys. So we use the same syntax that we would be using to grab a dog from our dogs object, but then we use the equal operator to say, actually, we're taking this key and we're assigning it a value. So now if we look at dogs, not digs, dogs, we'll see two good boys in there, Lola and Milo. And so now, if we had the same information stored in an array, like 2 strings about describing some dogs, and I said, hey, find the dog that is the bestest, or find Lola from the array, you would have to do a loop, let dogs, dog of dogs, and then you'd have to check, is the first thing in an array Lola? Is the second thing in the array Lola? In this case, our object could be thousands of items long. As long as we know what we're trying to get, we can access it just by going dogs. I don't care where this key is, but I want to get the value associated with Milo. And we get the bestest boy. So that's the first kind of advantage that we're going to see on objects compared to arrays, is that as long as we're storing key value pairs with keys that we're keeping track of, we can very quickly find things inside of our object. This syntax here is also going to be the exact same syntax for updating a key value pair in an object. So if we want to say Lola is now, I wanted to make this a competition of good boys, but we'll just do supreme. The supremist? Nah. Supremist?
Yes.
Let's do oh yeah. No, that's it. We don't want to go there. Yeah. That's a good one. Good pupper. So there's 2 options here. I mean, I already kind of said what this is going to do, but one would be like, oh, we're adding a new key value pair with also the same key. But in objects, we can't have that. All of our keys are unique. So I can only have one thing stored in this object with the key Lola. And if I reassign anything to that key, it's overwriting the current value of the thing in the object. So if we look back at dogs, we still just have 2 key value pairs, but I now have a updated value. There is a second syntax for both of these, where we can go dogs. Instead of square bracket, we can use a dot, and then we can define a key. In this case, because we're using dot, we're not evaluating some separate piece of JavaScript. We actually use the key name directly. So whereas before this threw that error where we had an undefined variable, this time we actually get the value. Exactly. When should you use dot notation, which is what this is called, and when should you use the square brackets notation? They're both going to do the same thing. I can even go dogs dot spot and say man's best friend. Same way I would have with square bracket notation, and I get a new key value pair in my object. So when are you going to use one? When are you going to use the other? My initial recommendation is to default to using the square bracket notation. You will be safer if you use this. But that's not like a great example or a great explanation. So let's look at why or what the advantages are to using the square bracket notation opposed to using like a dot notation. So in our example so far, we had relative knowledge of the things we wanted to get from our object. I knew I wanted to get Milo. I knew I wanted to get Lola. I might know that I want to get Spot. I can use that string value exactly as it is. But in larger programs, things are more dynamic than that. We have less control over what happens. We might have a program where a user inputs what dog they want to see. Or based on the logic of our program, we like do a test and we see, depending on which day it is, we only want to get certain dogs from our list of dogs for dog walking. Meaning there's an indeterminate result of the program. If I run my program on Tuesday, I will get a different list of dogs. If I run my program on Wednesday, I might get a different list of dogs. If I give the program to one user to type in what dog they want to see, they will type in a different user or a different dog than someone else. So if we want to go dogs dot whatever we do here, what happens if this is a variable or dynamic? Meaning, we might be a case where we have a dog input, or I'm going to say dynamic dog, meaning this could be Lola, or it could be Milo. It could be any number of dogs. I don't know at the time of writing the program. So it's something's happening here. If I now try and go dogs.dynamic dog, this is not going to do what I think it will. I'm not looking in dogs for the dog Lola, because dynamic dog is associated with Lola. I'm looking in dogs for a dog named dynamic dog. So if I try and access this right now, I just get undefined. Nothing exists in my object with dynamic dog. If I go dogs dot dynamic dog, and I set it equal to, like this is the does not exist. I can even have the case where like I'm trying to get a specific thing and I get something else. Whereas if I do square bracket notation, dogs of, this time if we don't include quotes, behind the scenes, this statement is becoming this statement because dynamic dog resolves to Lola, which is the equivalent to this statement. So all three of these in our particular case are the same, but we now see the advantage using square brackets. You can pick out things from the object using variables. So let's just show that that's an actual thing. Now we're getting the text associated with Lola, not with the does not exist dog. And just like we have before, we can use the same syntax for setting. So we have a program that says input the new dog name. New dog name. Someone says, we got some more dogs? Dusty. That's a good dog name. So we got Dusty. And then we're going to go dogs, square brackets of Dusty. As a program writer, we maybe don't know what this is. This is our view. We know there will be a variable called new dog name. We don't know what they've set it to. But then we come in here and we say, whatever they decided their dog name was, we're going to say the fluffiest doggo. Oh, see? That was my mistake. I'm using Dusty because I'm thinking, oh, I know what it is. But again, we wouldn't know it was Dusty. We would just have the new dog name. And we set him in there. We look at dogs. And we now see, we're getting a lot of dogs in there, but we see Dusty. So both work. If you know exactly what the key is, you can use dot notation. If you don't know what the key is and it's in a variable or it's dynamic, you want to use square brackets. There's no downfall to just using square brackets for most things, and when you know the variable, using quotations to say I'm actually looking for the string called Dusty, and then when you don't know it, using the variable. This is an area where I see a lot of people get caught up on. Later in the bootcamp, people will start going like, hey, like I'm using dogs, that new dog name, and like I'm setting a new thing in this, I'm not seeing it in my object, like it's not working. Or they're getting an error and they're like, what is going on? So I encourage you now, the activities for today and the rest of the week will help you, get more comfortable with this object syntax. But bring up this console every once in a while and just do like quick practices and experiments. Like make a basic object. Practice. Just give it some like random key value pairs. And then like practice. Oh, I want to grab this thing. How do I do it? And just try and get relatively fast at. Given an object, how do you grab this thing? How do you update this thing? Like the faster and more comfortable you get with this, and as close as it can be to second nature, when you go down and you get into larger programs, you won't run into so much problems. Any other questions on kind of just basic grabbing and setting syntax for objects?
So when is it really preferable to use dot notation? Because keys are strings, right?
Mm-hmm.
And so they can have like spaces and other characters in them.
Mm-hmm.
You can't call with dot notation doing that, right?
No, you can't. So the question was, when is it preferable to use dot notation? It seems like because keys are strings, they can have weird character like spaces and things. And if I'm going dogs dot, I'm trying to find a key that has a space, dog1, that's obviously not going to work. Like the space here causes a break in where it's looking. So even there's like an advantage to using square bracket notation. Just a quick note though, you will not want to index any objects by strings with spaces in them. You can, but it breaks convention, and this is the kind of reason against it. People will use dot notation to look stuff up, and it can cause problems. When is it useful to do dot notation? It can be useful. Sometimes you store a bunch of things in an object, and they're like hard-coded there. Like you make an object, and it has a bunch of configuration information in there. It has a name of a server. It has a name of the version. It has a name of whatever. And those things are always going to be server, version, build, whatever information you're trying to store. So you don't need square brackets for the dynamicness. You know that it's going to be so config dot version. You could do config square brackets version. And I think the argument to do the dot versus that type is just that it's a little bit cleaner looking, and it is clear that you're grabbing just a very specific thing from your object. But I would agree, when we're weighing them up, it doesn't seem like there's a whole ton that the dot notation has to offer us over the square bracket notation, and that's why I would just kind of encourage you to use square bracket notation as the default, but don't ignore dot notation because you will see it in other programs, other documentation, so you should be reasonably comfortable with it. So just to review, here we see an example where one of the values is an array. So we said earlier that the keys have to be strings, but the values associated with an object can be any valid JavaScript object. One valid JavaScript object is an object itself. So we can have this case where we say dogs, and we have a sub-object in here called puppies. And that is going to equal a new object that has some puppies, maybe, no, I think we got a spot. Doug? Doug the dog, that's a good one. Oh yeah. Silly me, not equal here, colon. So now we look at dogs. We see, I'll have to pop it bigger. We have a new key, puppies, and puppies actually has an object stored in it with another key value pair. We'll go dogs.puppies, and we see it's an object. So how do I get something inside of an object? So we could do dogs, puppies, and then we could just do another square bracket and get Doug. So again, this is the same as, so this is kind of like equivalent. It first resolves the first part of the statement and essentially returns Doug, colon, Doug the pug. And then once it has that, it calls Doug on the object that it just fetched. We could also do dogs.puppies.Doug, and we get the same effect. Yeah.
So, in that object, the value, we can have keys within the value. Would Doug be considered a key?
So the question was, within, if we have a nested object, can we have keys inside of what is essentially a value? Yes, Doug is considered a key, but it's not a key for dogs. Yeah, it's a key for the new object we created, which is like a puppies object. So we have one object, and then inside of it we have like a second object. Completely, you can even think of them completely separate from each other, except the parent object has a reference to the child object. Awesome. I'll send you these notes after so you can go through, but it's kind of some of the things we looked at. If we have an object and we have a dynamic value, we want to use the square brackets to get that object. If we use the dot notation, we don't get that object. Here's a probably super silly example, but if we think like, okay, there's a bank stores, is an old-fashioned bank, all of your money in like lock boxes. So in the back, they've got like a full set of like 1 to 100 lock boxes. You go, you sign up for the bank, and you get a number. This is your key to get your value or money from the bank. Your friend is like too busy to go to the bank, and he's like, hey, if I give you my key, can you go and get my stuff from the bank and get my like money? This bank has like 3 keys in it, or 3 boxes indexed by their key, and box 1 is $25, box 2 has $30, box 3 has $40. One option is your friend takes the key, he puts it in a box, and he gives it to you. We can think of this box as like a variable. So he's like, hey, like here's the key, here's this like box. I want you to take this box, go to the bank, give them the box, and then they'll get my money and you can return it to me. So he gives you the key inside of a box. You water polo over to the bank. You give that box to the banker, and this banker is smart enough to take the key out, use it on the lockbox, and get your money or your friend's money, give it to you, and you go to your friend, and he's happy. This is when we're using square bracket notation. The bank teller or our object is smart enough to say, you're giving me something that isn't the key. I'm going to look in, grab the key, and use it. The second option is if we're using dot. This is same thing. He gives us a key in a box. We go to the bank, but this time we get a silly bank teller. We give him the box, and he just takes the box and walks over to the boxes or the lock boxes and just pushes it against them, and then he returns. He's like, sorry, that key didn't work for any of my boxes, and you're like, dude, that's whatever, and then you return it to your friend. So you're not trying to use the literal box. It contains something. That's our reason for using square brackets. Sweet. From here on out, I think we're going to jump into making an actual program. So we are lectures. Today is week 1, day 3. I'm just going to make a new file, and we'll call this objects.js. And I will bring up the terminal down here. Just make sure our file's showing up, objects.js. And if we go console.log, hey there, and we node objects.js, we'll see, my syntax error. And then if we run it again, we'll see our thing. Okay, so let's make my idea was maybe we can make some objects around albums and artists. So our hypothetical application is someone comes in, they want to both look up what artists or what albums there are and who made those albums, and maybe they want to input a new albums and new artists. So we'll just start with what does an artist object look like. So our artist object will need to store some data in there. What data do we need to store around an artist? Name. Anyone got a favorite artist they want to throw in? Okay, we're going Kanye West. What else do we want to store? Genre. Gospel rap, yeah. What else? Name, genre. Their albums? Their albums. And we could store that maybe as an array. For now, we'll just go we'll throw a couple in there. Okay. So with this object, right now we've seen strings stored. We can do integers. We've seen arrays. I showed you an object being stored. We can also store functions in our value pairs. So for each artist, we might want to add a function that we can say add album. Or maybe to start with, we'll do a function that is print, or we'll just call it details. Details. And this is a function could take in any number of parameters if we wanted to. Just to demonstrate at the start, we'll just make a function that simply console logs this artist is, and we want to reference what the artist's name is. Eventually, this will be his name. And his genre or is, and then the genre. Have you guys seen these backtick and $ curly bracket string syntax before? Awesome. So anything between our open and closed curly bracket is going to be evaluated as JavaScript. So we can put dynamic things in there essentially. Right now, I'm just adding literally the string, so this function is not super helpful. But we can go down here, and I can do artist dot or square brackets details, which is the key within our object, retrieves my value, which is a function, which I can then call with some open and close parentheses. Anytime we have a function, if we don't use this, we just have a reference to that function saying like, hey, this is a function, it's a thing. The second we add this, we're actually using that function. So running our code, boy, I'm just hitting it out of the park. Console logs. We want to do double logs. So this artist is name, and his/her genre is genre. So we're able to store a function within an object and use them. A function that exists within an object is often called a method. It is still a function, but it is also a method. It's like, we have a big, we've got the big category of, this is functions, and a subcategory of functions is methods. I kind of want to show you guys something cool that we're going to talk about a bit later. It might be confusing, but we'll look at it anyways. So we want these to be dynamic and not referencing, just name and genre of the string. We want them to be the name and genre of our artist object. Our problem comes, name and genre here are not really variables. Like outside of this object, if I try to do a console log of name, I'm going to get first an error because I removed those things. Then I get an error because name is not defined. Name is not a variable, it's a key of an object. So in here, I don't have any, I can't use name. So to solve this issue, there is some special syntax when we're dealing with object. Well, it's special syntax in JavaScript in general, but it's useful when we're dealing with objects, and that is the syntax this. This always wants to refer to a parent object. So in this case, this is the worst concept to talk about because you're talking about this, and then you have to use this to describe it. But in this case, this will be referring to this object because it is within that object. So this is a synonym for artist in this particular context. So if it's a synonym for artist and we want to grab the artist name, what would we do if we use the variable artist? We could do .name, we could do square brackets, quotations name, So what will we do when we use this? Dot, and then name, and then over here, dot, and then genre.
So you could, instead of putting this, you could put artist.name there instead, or would that?
You can. I would recommend not doing that. And yeah, you can't. This has a lot broader use case than just what we're doing here. So if you get comfortable using with it, it'll. Yeah, I guess short answer, you can't. I mean, we can even demonstrate that. Let's use the first one to be this, the second one to be artist, and we'll run our function. And we get this artist is Kanye West, and her genre is rap and gospel rap. So that will work. This will also work. In this case, we're using this function as part of the method. If I take this function out, we'll do a test. So this should be const. And I try and do this. What is this referring to in this case? Artists? Okay, let's test. Oh, and we're not using it, so the first console log we see will be the one we already have seen. The second one will be this new test. So the artist is, we get an undefined, and her genre is undefined. That's for this one right here. So this always wants to refer to the parent object. This function is in the root scope of our program. It does not have a direct parent object that we can see. But this will still refer to something. So if I just console log this without the dot, we get something that called the object global. So within our Node application, our whole program is wrapped with a global object. So this reference will look up the chain until it finds a parent object. So it starts here, and it goes like, hey, at this point, is there an object? And it doesn't find one. So it goes not up in the code, but it goes up another context up here until it finds a wrapping curly brackets. It gets to the very top of the file and says okay, there's nothing, but there's the global object. So in this case, this will refer to the global object. Whereas here, when we use this, it checks upwards and it says, hey, I'm inside of an object called artist. That's what I'll have this refer to. Yeah. So this one is referring to the global object. This one is referring to artist.
So my question is that if you have another object other than artist on top of your file, and that global object, which one is it gonna refer to the top of one?
So you mean if all of this was surrounded by
If you have exactly the same thing,
something like this, and then I moved all of this code like this? Is that what you're thinking or no? Yeah?
So if you had movie stars as another object, would it catch that object instead of skip it all?
It goes to the first parent it finds. So in this case, I mean, this isn't valid syntax. I can't just declare artists inside of an object like that. I would have to do key value pairs, right? Artist, colon, something like that. But in this case, this would be referring to artist. And if we went, you would have to, it gets a little complicated. You might be able to do something like this dot this, but in truth, you're not going to be having code where you do that at this point, so we won't worry about it too much right now. But yeah, super good question. For now, I just want us to think that the easiest hint is when we are using a function, if it is tagged onto an object. So object.function, inside of this function, this will be the artist, whatever it's dotted onto. If it's not dotted on anything, it's going to refer to the global object. Yeah. No, you can use it anywhere. Oh, so the question was, I think, let me know if this is a question. Could I do new thing colon is this dot or this plus something else? Something like that?
Yeah, but this dot name, for example.
Oh, this dot name. Okay, so this dot name plus something. So that was our question. And we can check it out. So instead of doing our test stuff here, let's just console log our artist. So we get undefined and then something. So we can't do it in that case. And what happens here is this thing's parent is not the object. It is the object. Its parent is outside of the object. Whereas this is used inside function whose parent is the object. Just like if this is seeming confusing, that is okay. This is a confusing topic, and I think this lecture is designed to like introduce us to it. By no means are we going to feel super comfortable with all its kind of intricacies, but good questions. Next.
Wait, what happens when you remove this? The thing can still see the name if you remove this.
If I do this?
Yeah.
No, we're going to get like undefined, because remember, these keys are not variables.
What about can you put a variable over there? Like, can you put a variable, for example, we go above artist, above let artist, we let toolbar or something.
Yeah.
And then can we use toolbar inside?
Yeah, totally. So question is, if we declare a variable outside of our object, can we use that variable inside? Totally.
And also, is artist, when is artist created? Like, does artist happen the pull-up thing? No?
The hoisting?
Yeah.
Yeah, so the question was when artist is created, is it hoisted? Totally. So we could use console log artist here. And I'll put some string. Whenever you're doing console logs, it's always nice to have some like before define. It's nice to have some text to kind of distinguish it from everything else that's happening on the console. I'm just going to check, did we remove all the weird stuff that was breaking? Save it. So we run this. Artist is not defined. Artist before defined. Yeah. I'll have to look into this, because let test equal artist. Will this break it? The test is already test2. Yeah, we're gonna break in a second here, so I'll look into this
Like,
over the break.
and one more,
It might have to do with yeah.
I was just wondering what would happen if you use artist before foobar.
What would happen if we use? Okay, so the question was what would happen if we do this
Like no,
before?
no.
Like that?
No, again, drag the test like completely. Yes, and then drag test above foobar.
Like that?
Yeah, like this.
That shouldn't make a difference to.
Like I know
Yeah.
it's above, but if hoisting, then what happens? Like if we didn't declare foobar before we started using artist.
Hoisting.
Like does foobar also get hoisted?
Yes, but like the question was what because we've now lifted test 2 above foobar. What happens if like is foobar hoisted? Well, test 2 isn't using foobar at all. Like just because we're doing test 2 equals artist, and this is breaking, so it's not even doing this at this point. We're not creating the artist by doing this. We are just referencing it. So again, I'm gonna double check this over the break because I have some suspicions about what's happening, but I don't want to spread misinformation. Before we break, though, let's just review a little bit of what we looked at. So why objects? One big plus is that it's a faster lookup. When we want to find a particular dog, or as we build out this artist thing, a particular artist, and we know the name, we don't need to loop through anything. We can just say name and grab the thing. It's also just lends itself better to different types of data. Certain data works really well for key value pairs. When you're storing like a phone book, when you're storing a dictionary, that the data just comes in that format. This is not like, hey, we're moving away from arrays and you're just going to use objects now. It's that objects are really good for certain things and arrays are good for other things. There's some cases where you could use an array or an object, but it's just giving us more tools for us to use. We will take a break for 15 minutes. We'll come back at 11:18. I'll do some investigation into that hoisting thing. Although if it's overly complicated, I might just parking lot it and I can put some notes about it for later, because I don't want to kind of distract us.
Right. I think it's because hoisting only hoists declaration. Hoisting do not hoist assignment.
Mm-hmm.
So you can declare the object, it will get hoisted, but it will be only declared as an object, undefined object. You have to define it.
Mm-hmm. All right. Let me know, Victoria, if you guys are with us, and we'll start up. My bad about not getting some of those questions. I know that's like super frustrating on your guys' end. I feel like I started good, and then the wave of questions came, and I was not great. I will definitely. Oh, also, in Slack, if you just at me, I'll get a ping, and that'll be easier for me to get notified, I guess. I'll try and check the Slack channel a bit more frequently as well. Okay, we're gonna start back up, and we'll talk very briefly on the hoisting thing. I think it's definitely out of scope of today's lecture, but if we want to think about hoisting, we're raising all the variables to the top of the document, just the variables themselves. If we're using let and const, the variables that we have access to from the hoist are non-initialized. So if we use them, they will cause an error. The variable itself exists, so we could do something like this without declaring it. But if we try to console log something that is not declared, we'll get an error. Whereas if I did var instead of let or const, and we console log at the top artist, I'm not going to get this object, but I will not get an error because this name was hoisted, but it is initialized as nothing. So that's our first console log at the top here, undefined. Again, a bit beyond the scope, but that's the difference we were seeing beforehand. If you have questions around that, maybe find me after the lecture, or hit me up in Slack and we can talk about it a bit more. Before we go further, did anyone have any questions that came up over the break? And Victoria, did you have any questions that you were sleeping on? We can think about them before we go forward. Great. If anything comes up, just throw it in Slack or raise your hand and we can talk about it. We left off, we just had created our example. We have some key value pairs. We've seen storing values as arrays, storing values as objects. We found that we could also store functions as values, and when we store a function in an object, we call it a method. The next thing I want to talk about is the differences between the different types of data that we can store in JavaScript. So at the top of the lecture, we talked briefly that we have integers, we had strings, we have booleans, we have arrays, we have objects, and we have some of those, undefined null types that show up as well. These are the main pieces or types of data that we have in our wheelhouse right now. Do you guys, or have you looked at what are this group of variables, or this types of data called? Primitive types. And what does the idea of primitive types mean to us currently? Basic. And that's a good way of thinking about it, but anything behind the screen, like what does it mean? Sorry? They're not objects. That's another good way of describing it. What we're going to look at now is a little more kind of details in the difference between what we call the primitive type and what we're going to start calling. So here's our clear separator. We've got primitive types, and then what we have are reference types, or types that are stored by reference. So if we create a primitive and we set it to an integer, a string, a boolean, the same thing is happening. JavaScript behind the scenes is taking a piece of memory and it's putting the value that we store in there. I'm just going to clear out our page so we have some more room to experiment with this. So we have this. Behind the scenes, this is pointing, we can think of it like this, it's pointing to 5. So primitive is the number 5. If we then go, say, second primitive equals primitive, now we have the first one's equaling 5. The second one is also pointing to 5. But in the second one's case, it's a separate, completely new copied version of the number 5. And we can see that if I console log primitive, and then we'll console log the second primitive, second. And then here I'm going to say, hey, primitive no longer is going to equal 5. It's now going to equal 7. And then we'll copy this line. And we will see what our second value is. I guess we can also see what our first value is as well. OK. So running this, we see our first primitive and second primitive values both equaling 5. We update primitive to 7, and then we see its updated value, of course. Second still has 5. We are taking a box, and we are putting the literal primitive value inside that box when we are creating these variables. And that shouldn't be a surprise to us. That is how our code has been behaving up to this point. If we change this example and we start working with arrays and objects, however, something a little bit different is going to happen. So I'll keep the names primitive and second primitive just because we have the console log set up for them, but they are no longer primitive values. We can set an array here, 2, 3, 4. And then second primitive is now going to equal this guy. Actually, I don't like how confusing that is. These are now going to be reference. OK. Second reference is going to equal reference. We're going to log that reference. And then in here, we're going to alter the initial reference, and we're going to do a push. We'll push the value 8 in there. And then this is second. Any guesses as to what's going to happen? So we had one guess here that it'll change both. So let's run it and see. So our initial reference, the second one, they're both 1, 2, 3, 4. We push 8 into the reference, and we console log both, and we get 8 appearing in both of them. This is the core difference between a primitive value type and a value that is stored by reference. Bringing up here, we don't have that. We have reference is now storing a, and we can call this many things. We can think of it as a pointer. We can think of it as a location. But it is storing a location of the actual array. So when we say second reference equals reference, we're copying what reference is. So we get a new duplicate, this thing, this pointer, this location, but it's still pointing to the same spot. So this reference gets copied, but we're pointing to the same the same array. So when we do a push down here, we're interacting with the array itself, and we're adding in 8. And we get both of them being updated in that way. So this is both nice and something we have to be careful about. For instance, if here we said we actually want to copy it directly, and then we want to keep two arrays, one with 1, 2, 3, 4, and then the other one we want to change, well, then it's not going to behave in the way that we want. Where it becomes kind of nice is when we are dealing with maybe functions. So let's create a new add to a very silly function, but a function nonetheless, that takes in a number and adds it to an array that is passed into it. This function is trivial because all we have to do is do array.push, a function that already exists, and we'll push it to the array. Now we can do add to array. We can pass it a number, 10, and then a reference. Totally. I mean, that would the old one would work, but not do what we want. And then we'll do a console log of reference. So running this, we do get the new value 10 added to reference, even though within our function we're not directly using reference. We're using the value that was passed into the function.
How does JavaScript free memory? I mean, like if you create an array inside a function with let, and then you return that array, it's gonna return the reference to the array to the other places.
Yes. So the question was, how does JavaScript create and free memory? I'm going to push that one aside. It's a little bit too in-depth for this lecture. But what we were looking at here, this is kind of what I want you guys to think about when we're talking about memory. We have a space where the things are actually stored. And then in our variables, we have a reference to that location. JavaScript does a lot of the, like, when we're not using this anymore, it'll get rid of it smartly. It does a lot of that stuff for us.
So like we don't need to worry too much about JavaScript throwing away your array before you finish using it.
So the question was, we don't need to worry too much about JavaScript throwing away an array before you need to use it. Yes, as long as you still have a reference to that array. So I guess the example here is if we create an array, a new array inside of this function, new array, oops, and then we return this. Well, when we run this function, you know, this gets created and then we return it, but then the function's gone, so we kind of, the worry would be, hey, does this get deleted or removed? No, we'll be safe if we run add to array and we get the value from here. Save the value. As long as we have a reference to what essentially is this array, we can use it and not worry at all. But I think that we'll kind of not worry about that so much right now. We more want to think about the difference between primitive and reference types.
So one question is jumping back
Yeah, totally.
about that primitive and reference type. So the difference from that last example when you use .push, that's a reference type. So that's why it applies to both. That's what's going with it.
Yeah. So the question was the difference in the previous example we saw. The reason when we use .push that it applied to both of the array and the reference is because they're both reference types referencing the same thing.
Just to make sure one more time. So as long as our variable is an object or our variable is non-primitive, it's always a reference, right?
Yeah, so the question was, as long as our variable is a non-primitive, like an array or an object, will it always be a reference variable? And for sure. Array and objects will always be reference type.
So if you want to copy an object, you should always do some other complicated copy method.
Totally. And the follow-up was, if you want to copy a reference type, so here, like a true copy, you don't want to be doing this, because this isn't a duplicate. This is just a pointing to the same array. You have to do something beyond this in order to copy it. And you'll see those different things that come up. There are different ways that we can take a reference type and directly copy it, as opposed to just point to the same thing. Next, what I want to look at is, so we have our primitive types. Our variable is actually the number 5. We have our reference types. Then B is a pointer or a location where we can find thing 5. This affects how we share information, and this is the example that we looked at. When we just say B is going to equal A is going to equal, or A's value is 5, B's value is 5. They're two separate 5s. We're fine with that. It gets a bit trickier when we say B equals A and A is an object. Now, A is one kind of label of where that object is. B is a separate, different label of where that object is, but they're both pointing or referencing the same object. The next, totally. So the question was, this example here, is it the same as the little sketch I threw up? Hopefully I still have it. So yeah, it's exactly the same here. And if it seems not the same, it's probably because I was unclear. So we don't have the same code anymore. This would have to also be ref. No. Ooh, there you go. So if this is reference, this one creates a reference to the array. We set number to equal that reference. We are duplicating the actual reference. So we have two separate references or pointers, but they are still pointing, referring to the same array in memory. So we still have two separate variables. They're still different in terms of they are not physically in our program's understanding the same thing, but they contain the same information, which is just a reference to where that, it's like a treasure map where you're going to find the array. Like, hey, it's over here somewhere. Same treasure map, but there's two of them. Victoria, how are you guys feeling on this so far? Let me know in Slack if you've got any clarifications that need done. Okay, so because we have two things we're dealing with here, both the reference and the actual item itself, there's one last thing I want us to think about, and that is in the case where we pass in a variable to our function. So add to array, I'm passing two variables, number, which is a primitive type, and reference, which is a reference type. I then want to log after the function and see what they look like. Number, array we're pushing. I'm doing two things that are going to change or attempt to change what they are. So our initial number will be 5. We're going to push it into our array, and then I want to set number to 10. We run this. This is just a review of what we've just done. We see that 5 has not changed, or sorry, number has not changed, but the array has. When we pass this into a function, the number gets duplicated, the array has a reference to it. But what happens if I don't push to that array, but I just do something like this? I also want to set to 10. What will happen? We'll add 2 10s, so we'll see. Well, we know it won't change number already, because when we reset number to 10, this is a duplicate of what number is, so we can't change the original data. But with array, what will happen? What will be the second value in our console log here? So one option is that it will turn it into a primitive data type. So here, we're saying reference will be just the value 10 now. So that's one option. Any other guesses? The reference will remain unchanged. So the other option, so reference will be 10. The reference will remain unchanged, meaning it still points to 1, 2, 3, 4, 5. Okay, and those are kind of the, as long as JavaScript isn't going to throw a crazy curveball at us and just do something totally random, these are kind of the two sensible options that could happen. If we do run this, we see our output being 5 and 1, 2, 3, 4. So translated to our guesses, it's this one. So this is where it gets a little more complicated. And this is called, sometimes referred to as passing value by sharing. So we have this kind of case where array and reference, at least when we call this function in this instance here, both have a map to where the array is, but they're separate. Again, we have two treasure maps. When I do array equals 10, I'm saying, okay, instead of array now equaling this, let's change it and let's make it the value 10. This array variable is a separate variable from this reference variable, so I've only changed array. When I do array equals 10, I'm not jumping down the chain and talking about the array. The only time I can get to this is if I'm using arrays methods. So if I'm doing push, if I'm doing the square brackets dot thing, if I'm doing anything specific to an array, I'm jumping down the line. But in this case, I'm just overwriting what the reference was, not what the array was. So we get no change to the array.
So if you console log array ARR, would you get 10 after this?
So the question was, if I console log ARR, will I get 10? ARR only exists within the context of this function, so the best I can do is console log here. We'll do after assignment. And we will also do before, not before, for assignment. So you get before assignment, it's that array, and after assignment, it's 10. With console log, JavaScript is smart, and it kind of makes it a bit confusing for us, because behind the scenes, what this should actually be is before assignment here, this is like a reference. After assignment, it's actually the value 10. So JavaScript knows, hey, when you're console logging a reference type, you don't want to know just a bunch of numbers of where that thing is. You actually want to see the thing. So it does that a little bit of extraction for us and goes and fetches the actual thing that we're referring to and shows us it. So there's a bit of a difference there. Yeah, totally. So the question was, if I'm removing the reference to this array, how do I find it after I've changed it to 10? The answer is I could not find that array within this context, but I still have an old or like an existing like map that I've saved that we see over here. I'm console logging reference. So reference was created and is a reference to this array. I pass in only like a duplicate of the map. I kind of trash that map and make it 10, but I still have the old reference, which still is a valid pointer or reference to the object. Sorry? Yeah, so this one here, so the comment was this one is a copy that we're changing. Exactly. Array, let's walk through the steps. We start here, we create the reference, then we pass it into the function here. When we pass anything into a function, it gets copied for use in the function. It gets copied into a new variable name just for the sake of this function called array. And in array, we log it, which shows us the where it's pointing to initially. And then we change the copy, which is only a copy of the reference, not a copy of the array, to 10. And then we console log it, which would be 10. We exit the function and come down here. We still have the old map. We still have the old reference that is correctly pointing to this array. So we can still do things to it. We can still console log to it. It still is useful for us. Sweet. Great questions. This is, again, understandably a more complex thing. It gets a little confusing, but it helps to experiment with it. So make up a couple things like this. Whenever you notice, if you're seeing in your code, hey, this thing changed and I didn't want it to change, one way of debugging that is to see, is it referenced to by something else? Am I unknowingly editing it with another reference when I don't want to be? Great. We already looked at this to some degree. And again, this is just our introduction to it. It's also not a tool that we're going to be heavily using in the coming weeks. Later down the road, it might pop up more, but it's nice to get a head start on it. So this wants to refer to a parent object. In this case, if we console log this by going object, or if we run this function object.myfunc, this will refer to the object. The next thing I want to look at that kind of makes this different with our new understanding of references will be, we create an object. We'll call it our this test. It has some things in it, 1, 2, 3, and it has a function, and this is where we're going to check this. We'll check this out. It's a function, doesn't take in any parameters, and we're just going to console log where we say the current value of this is, and then we'll print this, and then we'll try 1 is this dot 1, and 2 is this dot 2. So is everyone good with that so far? Then like before, we're going to call this dot test, this test dot check this out. And just like before, we will see the current value of this is object. To get around this, anytime your console logs are doing object or array, console log is abstracting it for you. It's not showing you the details. If you log that thing as a separate argument in your console log, it will expand upon it. So we're logging this, and then we're logging all of this stuff. Now we get the current value of this is, and it's the object, and then we're correctly getting 1 and 2 from the object. That's review. But now we know that this function that we're referring to is a reference. We've stored, for the key check this out, we've stored a reference in here to a function. Functions are also objects within JavaScript. So we can grab that reference and pass it around or save it to another variable. What I mean by this is I can go let copy of check this out equal this test dot check this out. Note, I am not using parentheses, so I am not calling the function. I'm saying whatever value is associated with this key, so the reference to a function, save it in a new variable. This will be the function. Copy of check this out. So we have a copy, and we can see the copy when we run the code. So here's our log, the function, and then it shows the function that we have saved there. The catch, or the thing to remember now, is what happens if I use copy of check this out, a valid reference to the function that occurs here, and I actually run that function. This function uses this inside of it. Is there a difference between this instance or this run of the function and this run of the function? The answer is yes. And let's throw this up a bit bigger. I should do some cleaner. Oh, so the reason this is so horrible is, okay, here we go. So we're coming down, we're logging here just the function that we've saved, and then the first call to check this out using the object, we get current value of this is, and we get that it's referencing the this test object, and we can correctly grab values 1 and 2. Our second run starts here, and we get the current value of this object is object, the global object, and then just so much stuff inside of it. And our 1 and 2 are both undefined. This is where that tip earlier where I said, when you're using a function, try and think that this is coming from whatever occurs before it. So here, this is coming from the object that it's called on. When we do the second version, it looks back to see what it is called on and finds nothing. So it has to search for a parent, and it finds the global object, and that's what this is pointing to. Totally. So the comment was, before we were kind of naively looking at, well, this refers to the parent of the function, but it's actually, this is referring to the parent of the reference. And that's, again, we're throwing a lot of concepts on top of there. But here, this is a reference to a function. It's inside of this object. Here we have a reference to a function. It is inside of the global object. So that there's layers there, but like just the kind of dirty version of it is we are calling a method on a function a method on an object. That object is what this will refer to. If we are using a method or a function by itself, it's going to most likely be referring to the global object. And that's all we need right now. We'll build on that as we go, but this is a good fundamental understanding that we can kind of start to get comfortable with, and then add other pieces as we go forward. Any questions about this example? Is it clear how this new idea of a value by reference plays into the difference between these two? Somewhat. Hopefully a little bit. It doesn't have to be fully there. Here, our reference is contained inside of an object. Here, our reference is contained right here in the global scope. That's the main difference between our two calls of these functions. Sweet. If there's no other questions that you guys have, those are all the things I was going to cover today. I'll throw you guys these notes wherever they went here. I'll try and write up some of these, maybe the old example that we did and this one, so you can run through it yourself. And just in closing, I really encourage you guys, especially at the start, to treat coding as like a bunch of mini experiments. If you have an idea or if you're unsure about how something works, test it. Bring up the REPL, bring up the console in Chrome, make your own small program, and just like try and break things. And when they break, you can say like, I'm clearly not fully understanding how this thing works. The other part that goes along with this, I think sometimes people end up using mentors just as like debuggers, or like, hey, something's broken, or like, I don't really understand what this question is talking about. But you can also just flag mentors over to just hash out concepts with you. If after this lecture you're kind of still confused on primitive versus reference types, you could totally flag a mentor and say, hey, like I just want to review my understanding or like confirm my understanding on this topic. I think A, B, and C is that like makes sense to you, and they can help you work through those concepts as well. Great. I'll just check in. Victoria, you guys had any closing questions? One thing for you guys here in Vancouver, Victoria, when they're streaming in with us, they've got, the way YouTube has it, they've got like a 2 to 3 second delay, which is pretty unfortunate, and kind of makes it a bit harder because I'm asking you guys a question, hey, what about X? And then they have to, as a lecturer, I and other lecturers have to be conscious of that, so that I'm waiting an extra 2 or 3 seconds for responses, so that the asynchronousness of the stream I can get questions in a timely manner for them. Awesome. I'm stoked to see you guys. I'm stoked that you're in the boot camp. Hopefully I'll get to know you guys a bit more. I'll be mentoring today, and thanks for taking the time and learning a bit more about objects. Thanks, guys. Yeah. No, I love questions. It's